Sir, the right angle triangle.
Yeah. Uh, and we specifically started discussing the sides, the length of the different sides for which angles. What were the angles of the triangle?
What, sir?
For the right angle triangle, what were the angles of the triangle that we were looking at? What were the angles in that triangle? There were two specific triangles we looked at. In the right angle triangle, what were the degrees of the other angles? What was the size
60
of the
and
other angle?
30.
Yeah, 60, 30. Before that, we did the 45 degree, 45 degree, the 45, 45, 90, the isosceles triangle, right? Can someone tell
Yes,
what is the ratio of the sides of the both these triangles, the 45, 45, 90 and the 30, 60, 90? Can someone tell the different sides? What will the length ratios be? Who remembers the ratio of the sides of the triangle? Let's take the 45, 45, 90, that triangle. Can you tell me what are the lengths of the different sides? Fix any one side and then the other two will be fixed. Does someone remember the sides of the triangle?
Sir, 1,
No one
1
remembers?
and root 2.
Yeah, the two are 1, 1 and root 2. Now, if we make the hypotenuse 1, then what are the other two sides? So you can say that either the two sides which are where the right angle happens, those two are 1, 1, then this third side is root 2, correct? So this is the triangle. This one is root 2, this
So
is 1,
1
1.
by root 2.
Okay. Yeah. So if you make the hypotenuse as 1, then the other two sides are 1 by root 2, 1 by root 2. Correct. Okay. What about the 30, 60, 90 triangle? What are the different sides? Anyone remembers?
So the hypotenuse is 1 centimeter.
Yeah, assume the hypotenuse is 1. So if you fix the hypotenuse, then you can get the other two. The other two will be fixed. What are the other two sides for 30, 60, 90? No one remembers?
So 1 is 0.5.
Yeah. And the other one?
sir.
Sir,
Sahana, what
root
did you say?
3 by 2.
Yeah, root 3 by 2. Exactly. So the 0.5 is opposite which angle? And the root 3 by 2 is opposite which angle?
Root 3 by 2 is opposite
Root
to
3.
60-degree angle, sir.
Yeah. And
And
the 0.5 or half?
0.5 is opposite to 30.
Is opposite to 30-degree angle.
Exactly. Yes. Okay. So this is exactly what we had drawn last time. Okay. So this was the first triangle that we did, which is 90, 45, 45. Okay. And if this is 1, then this is 1 by root 2 and this is 1 by root 2. Okay. 1 by root 2 is about 0.7. That's actually 0.707. Okay. And then for 30, 60, 90, if the hypotenuse is 1, then the opposite of the 30 degrees is half. Why is it half? Because if I reflect the triangle around the base, then I will get exactly equilateral triangle. Why will it be equilateral triangle? Because this is 60, so this will also be 60 because the mirror image. And this will become 30 plus 30, which is also 60. So all the three angles will become 60. So this becomes an equilateral triangle. And because this becomes an equilateral triangle, you know that this is half. Okay. Once you know this is half, then you can use Pythagoras theorem to find the base. Because you know the base squared plus half squared is equal to 1 squared. So the base is exactly square root of 1 squared minus half squared, which is square root of 3 divided by 2. How much is this roughly? What is square root of 3 divided by 2? Can someone use a calculator or anything like that to find out how much this is roughly?
Zero 0.866.
Okay. Yeah, 2.866. Good. Okay. So I can do this if I tell you it is a 30-60 degree, 30-60-90 triangle or 45-45-90, then I could figure out this. But if I tell you some random angle, okay, like let's say if I tell you instead of 30 degrees, it was 35 degrees or 32 degrees or 40 degrees, then would you know how much is this height and how much is the base? Assume the hypotenuse is 1. So let's pick 40 degrees. Do you know how much is the height and the base if it's 40 degrees? So first of all, if the hypotenuse is 1 and you fix this angle 40 or something like that, is there a fixed answer for how much is the height? Is there some fixed number, fixed amount it will be? Or is it not known?
No, sir.
No, it will not be a fixed number? Mahalakshmi?
No, sir.
So if I give you this triangle, so let me just draw another one. I change this suddenly to make this say 40 degrees. Now this will become 50 degrees instead of 60. And all this is not, this calculation is not correct anymore. Okay. Now, is it the case, now this won't be half anymore. Are you saying that this will not have a fixed amount? If I know that the hypotenuse is 1. If I don't fix the hypotenuse, then of course, then I cannot tell what is the height. But if I fix the hypotenuse and I tell you this is 40 degrees, then will this have a fixed amount? Height and the base, Mahalakshmi, will have a fixed amount or will not be a fixed amount? So it's like this, right? I take this finger and I rotate it by 40 degrees. So pretend that this finger is 1 unit length. Now if I rotate this by 40 degrees, will it have a fixed height from this base? Or will it not have a fixed height? Anyone else wants to take a guess? Will it be fixed or will it not be fixed? Yeah. So Pooja, suppose I give you, suppose I give you such a triangle, and this hypotenuse is 1, and this is 40 degrees. Okay. So it's not 45. It's not 45 anymore. It's 40. Now, will this height? So this is 90 degrees. Okay, this part is 90 degrees. Will this height have some fixed length? Will the height be a fixed amount, or will it not be a fixed amount based on the given information?
Sir, it will change.
No, sir.
Change depending on what? What, how, like, it will change. What if I change, will this change?
Angle.
Which angle? This angle? Which angle? These angles? Pooja? If I fix these angles, then what? Suppose I'm fixing this to 40 degrees and this thing to 50 degrees. If I fix them, then is this fixed or can this have many, many possible answers? This height and the base. Anyone else? Anyone else wants to answer? Will the answer be fixed or will it be unknown? That means can it take many possible values? So let me name these some things. Okay. So this is A. Now, do you think so? AB is, let's say, the hypotenuse. And BC is the height. And AC is the base. And you are told that you're told that this angle of the A part is the angle of the A part is 40 degrees, the B part is 50 degrees, and the C is 90 degrees. Then does BC have a fixed length, or can the BC take many possible values? Sneha? And why? Why? Whichever answer you give. Yeah. Yeah, go ahead, Sneha. I couldn't hear. Maybe.
It has a fixed length, sir.
Yeah. Why does it have a fixed length? Why can't it take many possible values? Suppose I didn't tell you the length of AB. Suppose I didn't tell you the hypotenuse length. I only told the angles, the different angles are 40, 50, 90, 40, 50, 90, but I didn't fix the hypotenuse length. Then also would BC be fixed, or can it have many possible values, Neha?
Any possible values, sir.
If the hypotenuse length is not fixed, correct?
Yes, sir.
Okay. What if I didn't tell you the angles A and B? The hypotenuse is fixed, but I didn't tell you the angles. The angles are not 40, 50. There could be anything. 45, 45, 40, 50, 30, 60. Then is BC fixed or not fixed, Sneha?
Not fixed, sir.
Not fixed, okay. So if you fix both hypotenuse and the angles, then is it fixed or not fixed?
It is fixed, sir.
Okay. So let's do a poll. Okay, let's figure out what most people think. I'm fixing both the angles AB. And if you fix AB, then C is also fixed. Why? Because the sum of the angles is 180. So if I tell you A and B, then you can tell C from there. And I'm fixing the hypotenuse also. If I fix the hypotenuse and the angles, will the base and the height be fixed or not fixed? Okay. So let's do a poll. So you can answer, and you answer A if you think it is fixed and B if it is not fixed. Okay. Okay, remember, answer A if you think it is fixed and B if it is not fixed. So the angles are also given to you and the hypotenuse length is also given to you. If you are selecting A, means it is fixed and B means not fixed. Don't pick C and D. Just answer A or pick either A or B. Okay, still a lot of people have not answered yet. If you think it is fixed, then click A, choose A. If you think it is not fixed, then choose B. Okay, so half the people have not picked an answer. Okay, I think we are done. So let's see. So most people chose A, one person chose B. Okay. So let's see. Madhumita Pujar chose fixed. So Madhumita, why do you think it will be fixed? Madhumita, can you unmute and say why it will be fixed? Or Farhan, can you unmute, Farhan? Are you there, Farhan? Okay, let's pick another person. Let's pick Sanjana Todakar. Sanjana Todakar, can you unmute? Sanjana?
Yes, sir.
Yeah. Why will it be fixed? You chose fixed, right? Why will it be fixed? Can you give a simple reason or proof?
Because they
Or
have
anything why?
given the height of hypotenuse, sir.
Is only hypotenuse given, then it is enough, or you need the angles also to be given? Both angles and the height, angles and the hypotenuse to be given. You need both, Sanjana, both hypotenuse and the angles, or you only hypotenuse is given, but the angles are not given, then it will be fixed.
No, angles also needed, sir. So
Yeah. So can you give me a proof, like why, if the angles are given and the hypotenuse is given, then it is fixed? Why BC is fixed and AC is fixed? Is there some proof? Maybe you can think about using similar triangles. There's some theorem about similar triangles. If two triangles are similar, then some ratios are fixed. Do you remember that? Can someone think of a proof based on similar triangles? So Remember that if you fix given all the angles of the triangle, then all such triangles are similar. And in such a triangle, the ratio of the three sides, AB, BC, CA, is fixed. They cannot change. And now, because the ratio is fixed, if I tell you any one of the sides, then all the other two sides are fixed. Okay, does that make sense? Okay, if I don't give you the hypotenuse and I just give you the angles, then it is not fixed. But if I give you the hypotenuse and the ratios are all fixed, so once you fix one of them, then all the others are fixed. Okay, so BC has a fixed amount. Now, in the 45 degree triangle, the BC was exactly 1 by root 2. What about in the 30-60 degree triangle, BC was exactly half? What about in a 40-50-90 triangle? What will it be? Will it be more than half or less than half, first of all? Will this BC be more than half or less than half? If this is 40 degrees and 50. This is a 40-50-90 triangle. Anyone?
Some more.
More than half, sir.
Why will it be more, Mahalakshmi? Why will it be more?
So if the angle A is increased, then the line segment AB meet BC at the upper part of the BC. Sir.
Exactly, at a higher point. Exactly. So this angle A has increased from 30 degrees to 40 degrees. So in 30 degrees, it will be something like this, right? It will be somewhere like this. So 30 degrees will be somewhere here. Let me draw it better. Yeah, so 30 degrees was somewhere here. And you know that wherever the 30 is hitting, this part is half. So this has to be more than half. Okay. And will it be less than 0.707 or more than 0.707? Anyone? Less than 0.0707 or more than 0.0707? Do you know why am I saying 0.707? What is 0.707?
So no.
Remember, we found something was approximately 0.707. What was 0.707?
Square root of 1 by 2, sir.
Exactly.
1
1 by square root 2 is 0.07. Exactly. Will this BC be more than 1 by root 2 or less than 1 by root 2?
More.
Okay, why?
The angle A increases, no, sir.
Can you repeat that? Increases means what? So increases from is more than which one?
Its opposite side. Its opposite length of side will.
Just repeat that again. Opposite of length. Just repeat that. Whoever was talking.
Its opposite length of side will increase, sir, as angle A increases.
Yeah. So as the angle A increases, this BC will increase. Correct. Okay. But what was the angle A when this was 1 by root 2? In which case was this BC 1 by root 2? What was the angle of A that time when the BC was 1 by root 2? Yeah.
So 45 degrees.
Yeah, 45 degrees. Exactly. So when A was 45 degrees, BC was 1 by root 2. And now A is 40 degrees. So has the angle A increased or decreased from that case, the 45 degree case? Has it increased or decreased? So 45 degrees will be something like this. So this was 45 degrees. So this one was 45 degrees. And in that case, this whole length from here to here was 1 by root 2. Okay. So here will it be less than 1 by root 2 or more than 1 by root 2?
So less.
Less
Yeah.
Less than.
Yeah. So you know that BC is somewhere between 0.5 and 0.707. Correct? And you know it has some fixed answer. but we don't know yet what is that value. So in general, it is not easy to derive. For if I give you some random angle, some new angle here, like 40 degrees, 41 degrees, 42 degrees, anything, angle A, then I will not be able to tell you what is the BC just by calculating. But what they did is they said if the angle is theta, then they have a new function which is called sine. Okay, sine of that angle theta. So let me insert the symbol theta. Okay, so sine of theta. So the angle A is theta. Okay, is equal to BC, length of the BC. Okay, so this angle is theta here. Angle A is theta. So I'll just say this is theta is equal to 40 degrees. So it's just a new function, it's a new notation. Okay. So the height, which is the height. And for the base, you have, it's called cos of theta. So can someone tell me what is sine of 45 degrees? What is sine 45 degrees? What is the value of sine of 45 degrees? So sine of an angle is nothing but you do this, okay? What is sine of angle? You just take a right triangle where this angle is theta and you look at the height. The height of that triangle is called sine theta. And the base of the triangle is called cos theta. Okay. So what is the sine of 45 degrees?
Square root of 1 by 2, sir.
Exactly. Okay. Is square root of 1 by 2. What is sine of for 30 degrees?
1 by 2, sir.
1 by 2, sir.
Yeah. What is sine of 60 degrees?
Square root of 3 by 2.
3 by 2, sir.
Exactly. Yeah, square root of 3 by 2. Exactly. Okay. Why? Because I can just take this 30, 60, 90 triangle. I can just take this triangle and I can draw it this way. I can draw it this way. So this is 1, and we already know that if I take the 30, 60, 90 triangle and I just draw it, put it vertically, then it look like this. And I already know that this part is half and this part is root 3 over 2. Okay. So this is square root 3 by 2. Okay. What is cos of 45 degrees? Remember, cos is the base. What is the base in a 45, 45, 90 triangle when the hypotenuse is 1?
So square root of 1 by 2.
Square root of 1 by 2, sir.
In this idea is 1 by square root of 2. Same thing. What is cos of 30 degrees? How much is cos of 30? So it is just the base. Okay, instead of the height, it is just the base. So if you take A to be 30, then what is the base?
Sir, root 3 by 2.
Exactly. And in this particular triangle, BC will just be sine of 40 degrees. BC is equal to sine of 40, which we don't know. We don't know the answer to that. But we know that sine 40 is more than between 0.5 and somewhere between these two things. Between 0.5 and square root of 3 by 2. Because as you increase the angle A, the BC goes on increasing. Okay. Now, we don't know the value of this, but you can use a calculator to get this. So if people have access to a calculator, you can open a calculator on your browser or on the computer or anything. Can you tell me how much is sine of 40 degrees? 40 degrees. 40. 45 we already know. 45 we know is approximately 0.707. Can anyone tell what is sine of 40 degrees?
Sir, 0.642.
Yeah. How did you get that? Can you tell how you found that? Where did you search? Where did you look for this?
Sir, calculator.
Okay. So I can just share here. Did you use it on Google search or did you do it on another calculator? Okay. So this is this you can just do like the sine of 40 degrees in parentheses. Okay. And it'll give you 0.64. Okay. So for any angle, it is very hard to, if it's 45 degrees or 30 degrees or 60 degrees, it's easy to tell. You can calculate and tell exactly what BC and CA will be. For other things, you have to use a table or a calculator. So before there were calculators, the calculators only came sometime in the 1930s or 1940s, or not even 1940s. 1940s, the computer was built. So calculators actually became popular in 1970s or 1960s. Okay. But before that, what they used to do is they used to make these big tables. Okay, they used to write down 40 degrees, 41 degrees, 43 degrees. Or every angle, they are just written on a big table of the height and the base. Okay, and that's how they would tell what the height of the base would be. Like if you're, like let's say you're prepared building a road and the road has some slant or anything, you're building some, let's say you're building some bridge, you're building some cables for the bridge, rope for the bridge. Then the rope is at an angle, then you have to tell what is the, if there, how much rope is required for a given height, or if I know the rope length, then what is the height. So for all these things, you need to calculate. Okay, and since you cannot tell the height and the base for every angle by using calculations, you have to put it in a table. You know that the values are fixed, so they just actually measured it for different angles. They actually measured it for by changing the angle on paper or on by drawing on a using a compass and ruler and those things, and they recorded the values. Okay, so for any theta, that is sine theta is the height and cos theta is the base. Now, can someone tell me, if I know sine theta, can I get cos theta? If someone tells me what is sine of 40, can someone tell me what is cos of 40? How do I get one from the other? There is a simple relationship between sine theta and cos theta. Why is that? If you know sine of 40, then why do you know cos of 40? Can you get cos of 40 from there? Pooja Ashok. If you know that sine 40 is 6.64, from there, can you get cos 40 without using a calculator?
Yes, sir.
Yeah. Can you get the cos of 40 without using calculator once you know the sine of 40? So let's say you know that sine of 40 from the calculator is 0.64. From there, can you get cos of 40?
Yes, sir.
So how do you get that?
Sir, root 1 minus sine 40 whole.
Just repeat that once more. Yeah. What is it? What is cos 40? Root 1 minus? How will you get that?
Yes, sir.
Just repeat that again. 1 minus what? What do you say? Pooja?
Sir, root 1 minus sine square 40, sir.
Yeah, that's correct. Yeah. Why do you think you don't know? You're right. Okay. So it'll just be square root of 1 minus sine squared 40. Okay. I'm using this because the square root symbol is a little hard to write in this one. Why is it this? Because by Pythagoras theorem, what will happen? By Pythagoras theorem, the the base squared plus height squared is equal to 1 squared. Base squared plus height squared equal to 1. Okay. So you can just say that uh, height is sine theta. So sine squared theta for any theta, in fact, not just for 40. But any theta. Have you done this already? Have you done this sine squared theta plus cos squared theta is equal to 1? Have you done this already?
No, sir.
No? Okay.
Yes, sir.
You done it? Some people are saying they're not done, some people are saying they're done. So which one is it? Okay, let me write this in the square. Square also properly here. Yeah. So sine squared theta plus cos squared theta is 1. Okay, why? Because this is basically Pythagoras theorem. So who said it is done? Did someone say who's done? Can that person raise hand or mute? Or yeah, Prerna Hospeti, is it done?
Yes, sir. Sir, it was the first
Where
equation of identity in trigonometry basics I'm learning, sir.
okay, is that done in school or are you learning outside of it school?
No, sir. I'm learning outside, sir. It's for 10th, sir,
Okay.
in schools.
It is a what to that? Repeat that. It is what?
It's for 10th in school, sir.
It's in 10th standard, you're saying.
Yes.
Okay. Okay, yeah. So those who have not learned, sine theta is, so just to recap, sine theta is what? Sine theta is the height of a right triangle whose hypotenuse is 1. Hypotenuse is always fixed to 1. And the angle on this from the base is theta. Okay, so the height is sine theta and the base is cos theta. And by Pythagoras theorems, sine squared theta plus cos squared theta is always 1. And for certain angles theta, you can tell what is sine theta and cos theta, like 45 degrees and 60 degrees, 30 degrees. But for other angles, you have to use a calculator or you have to use the table. In the old times, they used to use tables. Now they use calculator. So this is just basics of like trigonometry. Now, have people learned things like if I give you an equation, then you can draw a graph of that equation? Like if I tell you that there is y is equal to x squared or y is equal to 2x. Have people done how to graph this equation? Or someone tells you that the speed of a car is, something, let's say it's 40 kilometers per hour. Then have people done how to graph as time increases the distance traveled by the car? What the graph will look like? How many people have done graphs or coordinate geometry or just graphs, basic graphing?
Sir, we had a.
Yeah, go ahead, Mahalakshmi. Repeat once more. What did you just say?
So the graph is done in our school.
You have done the graph? Okay. What about
Yes.
coordinate geometry, like equation of a line, equation of a circle? Those things are done?
Yes, sir.
Yes?
Yes, sir. Yes, sir.
Madhumita? Okay. So you have done equation of a circle?
No, sir. No,
No,
sir.
No?
sir.
What
No,
about equation
sir.
of a line? Equation of a line is done? Equation of a line, is it done or not done?
No, sir. No,
No?
sir.
Okay.
No,
Let's
sir.
let's look at basic graphs. Okay. So um so car is going at speed of, let's say, um 5 very slowly, okay? 5 kilometers per hour. And if I plot the graph of it, how will it look? Can someone tell how the graph will look? How will you, first of all, what is the meaning of graphing it? And how will you draw it? Okay, so in a graph, there are, like in a 2D graph, there are two axes. Do people know that there is an x-axis and the y-axis? Have you learned that?
Yes, sir.
Okay. So what will the x-axis be here? And what will the y-axis be if I want to show how far the car has gone in over time? What is the x-axis going to be and what is the y-axis going to be?
Sir, x-axis be time and y-axis be kilometers. Distance traveled.
Good, yeah, correct. Okay. So let's just draw that graph. And can you tell me how the graph will look in this case if it's going at 5 kilometers per hour?
Sir, a straight line.
Okay. And what will be the? Do you know what is the slope of a straight line?
Yes, sir.
Yeah. So if I draw x-axis will be time in hours, let's say, and the y-axis is, let's say, distance in kilometers. So this is x is time in hours and y is distance in kilometers. So let's say you have markings here, 1 kilometer, 2 kilometer, 3 kilometers, like that, and this is 1 hour, 2 hour, 3 hours. So it'll be a line, and the slope of the line will be how much?
5,
Can you
sir.
repeat? Can someone repeat? 5, exactly. The slope is going to be 5. The slope is exactly measuring, um, how much it goes, how much the x coordinate increases. Sorry, how much the y coordinate increases, divide for a certain 1 unit increase in the x-axis. That means how much distance it increases as you increase time by 1 hour. So the graph will look a line. So it'd be 5, something else, depending on how the scale. And now if you increase the speed or decrease the speed, what will happen to this line? First of all, what is the equation of this line? Can you tell me what is the equation of this line? Like what is y as x is changing? What is y? What is happening to y? If I tell you x, do you know what is y? Y is equal to. If I tell you x, can you tell me what is y in this line?
Yes, sir.
Yeah, what is it? If I give you an x, then how will you calculate y from there? At x equal to 1, what is y? If x is
So
equal to
1.
1 hour, then what is
1, sir.
5? If x is equal to 2, what is 5? What is y?
10, sir.
Yeah.
10, sir.
If x is equal to half, then what is y?
5 by 2, sir.
Exactly. So in general, for any x, y is equal to what? Y is equal to, as a function of x, what is it? What times x? To get y, what will you do? You will multiply x with?
Speed, sir.
Yeah, but here what will it be? Here the speed is 5. So y is equal to
5.
5 times x. Okay, 5x. So this line has this equation, y is equal to 5x. Why? Because if x is equal to 1, I'll put y, I will put y equal to 5. So actually the slope will be this. I should actually draw this line as a higher slope. So it will be something like this. Okay, why? Because at x equal to 1, the y should be 5. So when I take 1 here, I should actually get 5. So it will be higher slope. So this is, so does everyone understand that the equation of this line is y equal to 5x?
Sir.
If I draw, let's say 1 centimeter. So if I draw this x-axis and I make 1 centimeter here, and each centimeter here is representing 1 hour, and 1 centimeter in the y-axis, and each one is representing 1 kilometer, then this is equation is y equal to 5x. What would be if I change the speed to 2 kilometers per hour? Then what graph will I get? How will it look? Okay, let's take another car. Okay, car 1. So car 1 is going at 5 kilometers per hour. Car 2 is going at 2 kilometers per hour. So y equal to 5x is equation of car 1. What is the equation of car 2?
Y equal to 2x, sir.
Exactly. And how will that line look? How will it differ from this line?
So slope will
Yeah. So will it be below this line or above this line? Which one will it be? Should I draw it below it or above this?
below.
Below.
Okay.
Below.
Exactly. Yes. So this will be the line. Something like this. So this is car 2. So by giving some relationship between x and y, I get different curves. And I get different graphs. Okay. Now, suppose I give you a car which is not moving with a fixed speed. Okay. It is giving, it's actually, its speed is changing. So there is a car which is, there's a car 3 which is going actually has this equation which is y is equal to x squared. This car 3 is not, is it going at a fixed speed? If I say y is equal to x squared, that means after x hours, the distance it has covered is x squared. How much distance has it traveled in 1 hour? After 1 hour, what is y? You can look at this equation and tell me what is the value of y after 1 hour? So the car 3, is it first of all, is it going at fixed speed?
No,
Or is the
sir.
speed changing? Why do you say it is not a fixed speed? How do you know the speed is not fixed? If the speed was fixed, then y would be something times x, some fixed amount times x. So it will be like y is equal to 2x or 5x or s times x, where s is the speed. Here, y is not equal to some fixed thing times x. Here, y is equal to x squared. So it cannot be, it is not following some fixed speed. Let's just check, okay, let's check actually if it is fixed speed or not fixed speed. Let's calculate the value of y for different values of x. After 1 hour, what is the y value?
1, sir.
1 kilometer,
Yeah,
sir.
1 kilometer. After 2 hours, how much is it?
So
4,
4
sir.
kilometer.
4, sir.
Exactly. So the distance has increased from 1 kilometer to 4 kilometers. So it has traveled extra 3 kilometers in the second hour. 1 hour it was 1 kilometer. After 2 hours it was 4 kilometers. That means 1 plus 3 is 4. So 3 kilometers it has traveled in the second hour. How about in the third hour? How much has it traveled in the third hour?
9 kilometers, sir. 9
9 is the
kilometers.
total distance traveled in the 3 hours. But in the third hour itself, how much has it traveled? During the third hour, how much has
5,
it
sir.
traveled? 5, exactly. Why? Because after 2 hours, it was total distance was 4. After 3 hours, total distance is 9. So within the third hour, it has traveled 9 minus 4, which is 5 kilometers. So what is happening to the speed? So in the first hour, it traveled 1 kilometer. Second hour, it traveled 3 kilometers. In the third hour, it has traveled 5 kilometers. So what is happening to the speed of the car? Okay. So after 1 hour, y is 1. Okay. 2 hours, y is 4. 3 hours, y is 9. But during the first hour, distance traveled is 1, and during the second hour it will be draw this, take this a little bit up. During the second hour, distance traveled will be 4 minus 1, which is 3. And during the third hour, the distance will be 5. Actually, if you keep going like this, you will see that the distances are, it will become the fourth hour. What will it be? So it's 1 in the first hour, 3 in the second hour, 5 in the third hour. What will be in the fourth hour? What is y value at 4 after 4?
So
X
16.
equal to 4. Yeah. But so what is the distance traveled during the fourth hour?
7, sir, 7 kilometers.
Yeah,
7, sir.
exactly. 16 minus 9 is 7. So actually you can see it is becoming an arithmetic progression. The distance traveled is during the first hour is 1, second hour is 3, third hour is 5, then 7, and you'll keep getting the successive odd numbers. So the distance traveled each hour is increasing. That means what is happening to the speed of the car? Is the speed of the car fixed or it is going on increasing?
No, sir.
Yeah, what is that? Which one is it? The speed of the car is
Increasing, it's not uniform.
constantly increasing, right? So the person is constantly pressing on the accelerator. You're pressing on the pedal. So because it's pressing on the pedal, the car is going on increasing in speed. Because going on increasing in speed, the distance traveled during each successive hour is more. And when you add it up, you start getting y equal to x squared. Now, tell me how will the plot look? If I draw this graph, how will it look? Will it look a straight line like this?
No, sir,
sir.
curve.
Yeah. What kind of curve will it be? Can you tell me how the curve will look? Can someone tell how the curve will look?
So the parabola.
Yeah, exactly. Okay. So have you learned about parabolas already?
No, sir.
Can someone tell me about the parabola? What is the
No, sir.
no? Not look. Nobody. How many people have learned about parabola? How many have not heard about parabola? Okay. So for those of you who haven't heard, let's try to plot. Let's try to draw the points. What all the points will look? How will it look? Okay. So let's draw some points here. Let's put where all should I put the points? So the first point is x equal to 1, y equal to 1, right? So
Yes, sir.
let me mark that point. Yeah. So the point will appear. How do I? The first point will appear here. Okay. What the second point? Second point will be where? So this is x equal to 1, y equal to 1. Where will the second point be?
Sir, x
X
equal to
equal
2, y
to
equal to 4.
exactly. So that will be here. Okay. Third point will be
So
x
x
equal to 3,
equals
y
to
equal to
3, y equals
y equal to 9. Correct? This is 1, 2, 3,
yes.
4, then 5, 6, 7, 8, 9. Okay. This is 9. Actually, there'll be points in the will there be points in the middle also? Will there be some value of y at x equal to half, no, 0.5, 0.6, 0.7, 0.8? Yeah, so you'll get exactly. And let's calculate the values of the negative also, for negative x, negative. What will be the value? First of all, at x equal to 0, what is which point is it? X equal to 0, what is y?
So
Zero,
0.
sir.
0.
Sir.
Exactly. Okay. And since we are plotting a graph here, okay, let's look at the value on the negative side also. Let's say y equal to x squared is actually the y is the position of the car on a road. Okay, so it's telling you the position at time x. At 0th hour, it is at point 0, and then 1 it is at 1, 2 is equal to 4, and even for negative time, this so at minus 1 hour means 1 hour back it was at 1 square, and also at minus 1 squared, but minus 1 squared is same as 1 squared, so it'll be 1. So even at minus 2, it is actually minus 2 squared, which is 4. So let's assume that this equation is holds for all time, both negative and positive. So then at minus 1, which point should I draw? Where should I draw the point at minus 1? What is the value of y at x equal to minus 1?
1,
So y
sir.
is equal to
What, sir?
1.
Exactly. Okay. And then at minus 2, where did it be?
4, sir.
4, sir.
Yeah. So it is essentially it is symmetric, right? Symmetric around the y-axis. Correct? Whatever I see on the right side, the same copy I will see on the left side, like a mirror image. Okay. So this curve that I see, the curve that I see actually eventually will look like a U-shaped thing. Little bit like a U-shape, okay? And it's called as a parabola. So it looks something like this. Okay, look like this. Oh, wait. Okay, so it'll look actually like a U-shaped thing. I didn't draw it passing through the points properly. But let's just plot it exactly, okay? So we can plot it on calculator or on Google. So, okay, plot y equal to x squared. Okay, you see this?
Yes, sir.
Yeah. So this plot is exactly y equal to x squared. Okay, this is called as a parabola. Now, a similar shape is observed when you throw a ball. When you throw a ball at an angle, you also see a U-shaped curve, like a parabola. Can someone tell me why you see a parabola when you throw a ball? What is the connection between parabola and when you throw a ball? Oh, your mentor meeting. Okay, so looks like you have a mentor meeting. So let's close today. Yeah, let's continue next time. Okay, think about why there's a parabola coming up even when you throw a ball in the air at an angle. So don't think that you're throwing it up. You throw it up, then it goes up and comes down. But if you throw it at an angle, then it becomes like a parabola. Okay, so think about it and let's discuss it next time. Okay, thank you. Bye.
Thank you, sir.